So this is chapter 12C related to linear functions. Now I'd like you to note this stuff as I work through it, so then you've got it in your notebooks as so then later on when you work through the questions you can look back on these notes. So it should be familiar from previous year's work that if we have some straight line on a Cartesian plane, we can describe that line using the equation y equals mx plus c, where the m represents the gradient or the slope of the line, and the c represents the y-intercept, so the point where the graph intersects the y-axis. So that's the first thing that I would like you to note in your exercise books. If we have some Cartesian plane, remember to always label your axes y and x, and I've got some line that passes through it. Then this line, which is continuous, can be described by y equals mx plus c, where c is that y-intercept, so the position where the graph intersects the y-intercept. So we can see on here they've labelled it c, and the gradient or the slope is given by m. So this is point C, and the gradient of this graph is given by m. So this is the gradient, and this is the y-intercept. So let's have a look at example 3. So the graph alongside shows the height y millimeters of a candle x hours after it was lit. Find the equation of the linear function connecting y and x. So in this example we need to use this graph that they've provided and the information that we've just discussed to find the equation of that line. So we're going to use the form that we just showed, y equals mx plus c, where m is the gradient and c is the y-intercept. So to find the slope of any graph, basically we just need 2 points on that graph. So the easiest point, or definitely one point that I would be using if I was trying to find the gradient of this, would be at x equals 0, y is equal to 90. So that's 1 point, and then I can choose any other point on this graph to find the slope of this graph. So the other point that we're going to use here is if we come across to 5, and it intersects nicely on that intersection of two lines there, which gives us 70. So the 2 points I'm going to use are 0, 90 and 5, 70. So this is example 3. Part A. So the line passes through 0, 90. So remember that's our x coordinate and that's our y coordinate. And the other point we said was 570. So there's 0, 90 and here's 570. Now if I want to find the gradient, remember from last lesson, the gradient is equal to y2 minus y1 over x2 minus x1. Now it's just a matter of substituting these values in. Just so you don't make a mistake, you might want to just label what each of these are. So this is point 1, this is point 2, so therefore this is x1 and this is y1, and this would be x2 and this would be y2. So now it's just a matter of substituting these values into this to find the slope. So y2 is 70, minus y1 is 90 over, and then x2 is 5 minus x1 is 0, which is going to give me minus 20 over 5, which can be simplified to negative 4. Now, notice that this graph has a negative slope, and that's why when we've determined our slope here, there's a negative in front of the 4. If the graph was slanted in this direction, then it would have a positive slope. So we found the slope now. If we look at the y-intercept, it's at 0.90. So when x is equal to 0, y is equal to 90. That's the y-intercept. So the y-intercept is equal to 90. So there's no calculation that we have to do there. We purely do that by observing the graph. And then finally, we know that the equation of a straight line is given by y equals mx plus c, where m is the gradient and c is the y-intercept. So therefore, the equation of the straight line is y equals, and our gradient, which is m, was negative 4. Then you leave the x where it is, and then our y-intercept was 90, so it's going to be plus 90. So you can see y equals negative 4x plus 90. Then they would like us to find the height of the candle after 12 hours. So obviously as the candle is burning, the height is getting shorter and shorter and shorter. So this graph has shown us, if you want to give it some context, before they light the candle, it's 90 millimeters tall. And then when it gets to 5 hours, it is 70 millimeters tall. And then when it gets to 10 hours, it is 50 millimeters tall. Now, our graph doesn't show us all the way to 12 hours, so this is where the equation of the line becomes useful. So, part B, find the height after 12 hours. Now remember that x was representing the amount of time taken. So x is representing time in hours, and the y is how tall the candle is in millimeters. So if I want to know how tall that candle is after 12 hours, all I have to do is substitute the value into our x here. So this 12 will be substituted in for x, and that will tell me how tall the candle is after 12 hours. So y will be equal to negative 4 by 12 plus 90, which is equal to negative 48 plus 90, which is equal to 42. So therefore, the candle is 42 millimeters tall after 12 hours. So if I wanted to know the height of that candle at any time, if I wanted to know how tall it was after 8 hours, I could substitute 8 in for x. Or if I wanted to know how tall it was after 7.66 hours, I would just substitute that value in for x. So part C, the last part of the question, asks us to find out how long it will take for the candle to completely burn out. So what they're assuming is for there to be no wax left. So that means that the height of the candle will be 0. So remember, the equation that we determined was that y was equal to negative 4x plus 90. So for the candle to completely burn out, the height will equal 0 millimeters. So therefore, minus 4x plus 90 will equal to 0. So we want to find what the x is, because x represents the amount of time taken for the candle to burn. So this is just a matter of rearranging this equation. So again, if we have positive 90, we have to subtract 90 from both sides because we're trying to isolate the x. So this means that I'll have minus 4x is equal to, it will be 0 minus 90, which is going to give me minus 90. And then I've got minus 4x is equal to 90. Therefore, to get rid of this minus 4 in front of the x, I want to divide both sides by minus 4. So this will mean that I'll get x is equal to minus 90 over minus 4. Therefore, x is equal to 90 divided by 4 is going to be 22.5. 22.5. And then you just need to finish the question off with a quick statement. Therefore, the time it will take to completely burn out is 22.5 hours. Make sure that you include your units, because remember, they show here that time is measured in hours. So what I'd like you to work through now is question 2, 3, 4, and 5 of the attached document. So could you please just work through those questions, and the ones that are unfinished, can you please finish for homework?